Hey, Mr. G here. We're going to demonstrate in this tutorial how to balance chemical equations using the chart strategy that I taught you in the lesson. What we always want to do whenever we see a chemical equation from this point forward is to always check to see if it's balanced first. Sometimes in a problem, the chemical equation will already be balanced for you. But many times it will not be, so you always want to check and make sure you balance it first. Of course, in this problem it's not balanced. That's the point of what we're doing. So we want to always make our chart first. And remember, when we're making our chart, the way we construct the chart is to have one column on the far left where we place the elements that are in the equation. Doesn't matter what order they're in, just need to make sure they're all there. And then we have a nice dividing line that separates the reactant side from the product side. Nothing fancy, just something to help you know which side you're on. And then we make our rows across for each element that we're going to be counting. Then the first thing we want to do is we want to count all of the elements' atoms that are present on each side of the equation. We have the reactant side, and we have the product side. So, we start with phosphorus, and we start with the reactant side. We can see that we only have one phosphorus atom present. So, we'll write a 1 on the reactant side. Then we go to the product side. Again, only one phosphorus present. We'll do the same with chlorine. Chlorine, it looks like we have 5 present on the reactants. Products, only 1 present. Next, we move to hydrogen. Look across, we only have 2 hydrogen atoms on the left. On the right, we've got 3 here plus 1, which is 4. And then oxygen. Looks like we have 1 on the left, the reactant side, and then we've got a subscript here, so 4 on the product side. Now that we know exactly how many elements, or excuse me, how many atoms of each element we have on the reactants and product side, we can start balancing our equation. And remember, the advice is to always start with the most complex compound that's present. 9 times out of 10 that's going to work. At least it's going to work best for you. We'll put it that way. So we want to look within that compound and see what we need to balance first. Now it looks like phosphorus is already balanced. So let's go to the next element that makes sense. Remember, we want to always save oxygen for the end. And so hydrogen is the next sensible thing to balance, according to our rules. So it looks like we've got 4 hydrogens on the right and we have 2 on the left. So if we want to balance hydrogen first, then it makes sense to put a 2 coefficient in front of the 1 on the left, the water on the left. So when we do that, that gives us the 4 that we need. So we'll cross out our hydrogen there, we'll put the 4 to balance the waters. But we can't forget about the fact that by putting a 2 here, we've not only changed our amount of hydrogens, but we've changed our amount of oxygens as well. We now have 2, so we have to change that as well. Now we reevaluate. We look and we see, okay, I've balanced my hydrogens, I still have my phosphorus balanced, my chlorines are unbalanced, I want to save oxygen for the end. So let's move to chlorine then. Okay, well, I've got 5 chlorines here on the left and I've got 1 on the right. So the only thing to do to balance that out would be to put a coefficient of 5 here. Okay, so I put a coefficient of 5 there. I've changed my amount of chlorines on the product side to 5. But what have I also changed? Well, I've changed my hydrogens again, so I'm going to need to go back and fix that. Well, that's okay, and sometimes that happens. That's why we have the chart in the first place. So I no longer have my 4. I've added 5 hydrogens plus the 3 I have over on the left, which is now 8. That's an easy problem to fix. Now that I have 8 hydrogens on the right, let's go ahead and fix that mistake that we made initially by erasing the 2. And what can we do? Well, we just make it a 4, right? By making it a 4, 4 times 2 is now 8. And that fixes our hydrogen problem. Again, since we changed a 4 here, we need to address the oxygen. So now we have 4 oxygens. Okay, well that helped us out because it not only altered our hydrogens and got them balanced, but it actually ended up balancing the oxygens. So now we have a completely balanced equation without even having to separately balance the oxygens. So our finalized balanced equation is here. And this is why that chart method is so useful, because it helps us organize everything. And that first step we made, when we followed the rules, may not have worked out for us initially, but it still, by using the chart, helped us keep everything organized so that we went to the chlorines and balanced them. It was easy to go back and fix our mistake by simply crossing out what we had and moving forward with the process that we knew was right. So now it's your turn. We'll give you a couple of reactions to balance on the next slide. Make sure you use the chart. Don't try to do it in your head. Use the chart and you'll get the answer right. It may take you a few steps like it did here, but you'll get there. You'll get the answer. Always check your answer at the end.